Alright, so let's start here. So last time we did, yeah, we made some changes to the dialogue system to make, because there was a bug where some of the state was not saved between like scene transitions, but now that is corrected, and yeah, the dialogue system basically we have we have these options which are basically like, what do you say, like one unit of dialogue, you could say. So you have the text that's supposed to be shown. You have an optional label if this like option is something that you're supposed to like choose from a list to get. And then you have responses if you also have responses that you can show so that the player can respond to this text. And then we also have this on-end hook, which is like you can set something to happen when this dialogue option is like is done, when you reach the end of it, which would be like after this text has been fully displayed, basically. And then we have a place where we like define all the dialogues for every dialogue. So we basically have a, let's see here, dialogues. So here's all the dialogues that we have, dialogue options, and right now, and they each have their own sort of unique key here. So this is just an enum describing those, and then we have this dialogue option or dialogue options, which is a struct. Well, this is a type, which is a struct type that takes all the option keys and makes it a dialogue option. This thing actually I made before I realized that there was actually a built-in thing for this, I think, in, is it standard meta and then like enum. Where was that? I believe I saw that somewhere. I think I did anyway. Container layout, what is that? Oh, I see. It's like, okay, something else. But I think I saw somewhere you could take an enum, and then you make a struct that is basically has all the enum like tags as fields, and then each field type would be one type that you put in. Field type, no, field type just takes, like, gets you the type. Okay, I'm pretty sure I saw it somewhere, but anyway, basically what this does is it takes this enum, it makes a struct with all these enums as fields, field names, and then the type of the fields are this what you put in here. So you get out this struct we're using here, which basically means that you have to implement all of the fields in order for it to work or compile. And so if I, for example, add another one here, start 3, then we're gonna get a compiler error where it says missing struct field start 3. So that's how you would like add a new dialog option. And then these options are basically just initializing dialog option with different things. So here, for example, we have start. So we also distinguish between starting dialog and non-starting dialog. So starting dialog is basically the first thing that you enter when you start a conversation, or you go up and talk to an NPC. The starting dialog is what's gonna be there. And so each NPC basically has a starting dialog set to them in the state. They have a default from the sort of default, like the start. For example, if we go to NPC and we have somewhere so here you give starting dialog to an NPC. That's where then we add a dialog component to the NPC, and we pass in, among other things, the starting dialog. So we know from the start which starting dialog the NPC is gonna have. However, you can't change the starting dialog. If you provide an action that is change starting dialog, and they provide a key to the option that is going to be the starting dialog, the next starting dialog. So basically, this means that once you talk to the NPC, we first show this dialog here, and then when you next time, like, because this is the on-end hook, so this will be called after we've talked to this guy once. So the next time we talk is going to be Elder Star 2, so then he says hi, and then there's no actions on end on that. So that's the starting dialogue. It basically has a text to show and what's happening at the end of that starting dialogue. Okay, and then we have like this normal dialogue options, like this is just a test here, but it's like an option called waiting. So that will be the label that's shown as the option that you can pick from different like options, dialog options. Here's the text that it will show when you pick the option, and here are like different responses that you can give to this option. So if you choose OK, then you will accept. We have an action that happens when you choose a response, and for this one you accept the quest, which is a quest here. And then no thanks will end the conversation. So that's how the dialogue system works. I'm not sure if this will cover all the bases that we need later, but if we need to do some other things with the dialogue that this system can't handle, then I guess we have to, you know, redo it a little bit. But I think it's pretty extendable. You can like add any type of actions that you want, and I guess the only thing that is kind of like static here is like the dialogue, or basically you talk to the dialogue, you talk to the NPC. We always show the starting dialogue. When that is done, we always show the currently available options that you can pick from. So basically dialogue options. Then you pick one of those, and then it's gonna show the entire dialogue option, like this text here. And then you're gonna show responses to that as well. And then it's also connected to the quest system, where we can advance a quest, and that will advance a quest in the quest system. So But anyway, so the thing that we did before was that starting dialogues was actually not in here at all. So starting dialogues was like its own thing, and I had kind of overlooked how we stored those. And so I thought that, okay, but it does make sense that starting dialogues would be here as dialogue options, or it's not really an option, you know, but it's a kind of a bad name, but it's like this dialogue option is basically encompassing everything you need for one part of a dialogue, basically, or when talking to an NPC. So you have like the option label, the text that you're gonna show, and responses that you can get, but also now we have on end here as well. So I kind of just merged that what we did last time. So we merged the starting dialogues and the dialogue options, so now they are one and the same, so that we can handle them the same, and it actually cut down on a lot of code. So I'm actually gonna go and see if, well, if we go to the dialogue thing, one thing that we need to do from last time is actually run the on end action, which we're not really doing. So that we need to fix. But here we also have a whole bunch of places where we now have this, so special handling for the starting dialogue, which we can now delete, because now everything is handled in this one instead, like active dialogue is it called now. So we can basically just delete all this, all this. See, was there anything else? I think it was like handle starting dialogue here, yeah. Was there anything else? No. Right, so yeah, and we do have these special handling cases now, but it's basically everything is handled the same except for a few certain parts. So basically for responses, basically it's like we're handling like the input here for active dialogue, and so this function should show responses is only going to be true if you're at the end of the actual dialogue. And so, and that's going to be different for like the starting dialogue and the active dialogue, because the starting dialogue is going to show the available options, while the active dialogue is going to show the responses that is tied to that specific option. Which we might be able to, you know, merge later, but this is just how we did it right now. And yeah, and basically once you're in here, we actually wanna also run the on end action as well, I think. I'm wondering if we should do it after the like it's closed, or if we should do it also, I never thought about this, but this might actually return an empty slice. So if this is 0, then I guess we just I think we have somewhere here. No, we did add here. I guess it's going in here instead. So we kind of skip this part on the starting dialogue, but not on... I think we need this... Let's see. Does this handle? Okay, so if the length is 0, then we simply do this, I think, yeah. Well, isn't that kind of weird? Well, maybe not. But we should be checking for the accept as well. Okay, let's see. I think the idea is this. Wait, this is a different one. Yeah. I think the idea was this, that we go in here if we only show responses. If we have responses, we do the handling in here. If we don't have responses, then we do handling here, which handles the on end. However, I think I want to have this like the on end should be handled in both cases. So yeah, handle choose response. That should trigger the on end on the previous conversation, I think. So we're gonna have the dialogue there. Actually, no, it's gonna be option. And we also need what is a? Oh, that's the action, right? Option. We need the target and T. All right. Okay. Right. So now whenever we choose a response, we're doing that. However, here I think that we actually, this one we need more information. We need to know how many, like, do we have any shown options. Or we can... Well, let's see. Let's actually do this. So let's, if we have a starting dialogue, right? And then we have a separate thing for that. I'm just gonna type this out so we can, if we can see that maybe structured differently. So basically we do all this. We should still have like cancel and accept. Alright. Cancel just cancels out. Accept. We'll check if we're done. We run the on end. If we had actions, well, yeah, so let's assume that we didn't have any responses in here. Now here we want to say shown we want to get those. All right. Put it in here. So we don't need the info though. And then we can say actually, let's just return this. Now this would be that looks we need the target. Yeah. All right. Right. So now we have the shown options. We can check now if is done, right? And shown options length is more than 0. Then we want to handle this differently. So what happens then? Well, then we want to show the options. So it's going to be handle starting responses. Right. And then we could even do it so we pass them in instead. So we don't have to like double allocate this at least. Okay, so that's for the starting dialog. And then we have the other, which is when it's not a starting dialog, which should basically be the same thing we have here, except we just do that. This is going to be handle on end. And then we end it. So as we can see here, it's a lot of things are the same, like the else ifs are the same, and the only thing that's different is this part, where I think what we'll do is we'll say if we have a starting dialog and we are done and shown options is more than 0. Then we have else if we are not a starting dialog and we should show responses. There we go. Alright, we need... Alright. And we probably just wanna... This is infos, responses. Um... Alright. Okay, yeah. Yeah, because we need information to show from shown options here if it's more than 0, so we can't move this into here. We need to know if we're handling the starting dialog responses, or if we don't have any responses, we go down here and we handle on end here. We're not gonna do it on cancel input. Possibly because cancel inputs doesn't really check. We don't really know if we're well. Yeah, I don't know. It's like I'm not exactly sure. I don't know if we even want to have cancel input as a thing you can actually do, because then you can potentially miss a bunch of stuff. And I mean, yeah, the thing how it works right now is you can basically cancel out of any dialogue at any point in time, basically. And I'm not sure if that is good, because then, yeah, as I said, you might miss dialogue, or it might mess things up. You might miss that you can grab quests. You might miss a whole bunch of stuff. So I think it's probably better if you are basically forced to complete the dialogue instead. But yeah, we'll see. It's an easy fix because we just remove this, and you can't do it anymore. All right. So that now we have a little bit of, I think, better way of doing this. I don't like, that we have to allocate this. There's like 3 allocations happening here. One is here where we are basically doing this. Actually, maybe it's even more. Yeah, so here we're basically looping through the states and basically filtering those that are shown. We could do this with an iterator instead. We could actually make an iterator for this. I wonder if there's like a. It would be cool if you could like add a snippet for iterators, so you could like super easy just write a small iterator because it's not that much of code. We had last stream, we explored a little bit on making more like composable iterators. I made a little small like iterator library, and the idea is basically the same as allocators. You can pass in, just as with allocators, that you can use a sort of like generic interface here. So this is generic for all iterators that we have here. So we have next and reset, and so I guess reset wouldn't work on like all iterators, but it works for those that we have right now. So I have reset there just because it's. You might want to have like one that is resettable generic iterator and one that is not resettable. But anyway, we have this generic iterator, and it works the same as allocator, as I said. So we have what you return is a pointer that has the data that you need, which has to be a pointer here because Zig doesn't know the size of the data, so it can't reason about how to make this struct without having this be a pointer, because pointers are always the same size. And vtable is just that's like a comp time description of which implementations you want to use for next and reset, which we're accessing here with vtable next and vtable reset. So, but the issue really with this system is that since we have to have a pointer here, then it's pretty hard to have a function that returns an iterator directly. So what we have to do is, because the issue is where will the data be stored. That is the issue. You could put inline into the function, but I'm not sure if that will. We talked a little bit of that with last stream about this, and like we're not sure where this will, like, if this will work, if an inline function will work when, for example, you do like optimizations or change something. So all of a sudden, all your iterators are gonna fail. However, there is a workaround. So what you do is you create your iterator struct in where you want to use it, and then you call a function on that which returns the iterator. So let's say here, for example, we have the slice iterator, and this is very simple. It basically takes a slice, which I have here as any type, but it's supposed to be a slice, and it returns an iterator like this, a slice iterator, with these, like the type of slice here, the element of the slice. And so it basically creates an iterator that iterates through a slice, so each element of the slice. And you can pass in any type of slice here. So what we return here is this struct here, which this is the data, and that data is like different for each iterator. So that's why we don't know beforehand like okay, how big is this iterator gonna be, so we can like store the data there. That's why this pointer has to be any-opaque. I mean, I guess technically, if we put a constraint on the iterators to say, okay, you can at most store one pointer to your sort of source and then an index, because that's probably a pretty common, you know, practice, or sometimes you don't even need the index. And so what you could do then, actually, you could have the data be like a U8 like this, a mutable array of, well, how many bytes do we need? We need one for the pointer, which is 4 bytes, or wait, no, it's 8 bytes. And then we need another, I guess we could put another 8 bytes. So I guess this would probably work if all our iterators have this amount of data. We could just copy that data, and that will be our... So what you could do, I'm gonna actually try this. I'm getting excited here. This would put the constraint that the structs can't be more than this size here. Hang on a second. All right. So anyway, yeah, let's try this. So this would be, instead of self pointer, we put self data. All right. Now here we actually take so iterator data is at max is like 16 U8s. I guess it has to be mutable though. Hey Two Step, welcome. Yeah, I just, you know, I just went through like that we did this last stream, and then I went back here and I was like, wait, can't you do this? So I was thinking about having this data be like copyable, or like if it's like this, I wanted to try why couldn't we just pass it in like this? Yeah, so the idea is that we don't have a pointer here. We have just the data straight up. But the data is, since iterators are like, what I thought is that at most they would have a pointer and an index basically as state. They might have more, but the ones that I'm using here has only those. So what I was thinking is, okay, we could store that data as a byte array and then just use it like that. So basically, yeah, converting this, we could possibly convert this byte array into, wait, is 16? Yeah, that should be fine. Into the data that we need here. And so we convert it into the type that we need. And we just, yeah, I guess maybe a bit cost works. I'm not sure. There might be other, this constraint, so you can basically only have like an index and a pointer. But it should work for these As long as you keep to that, it should work, right? Yeah, we still get, well, we don't really get, well, yeah, okay, let's see. So next, now this would be the data instead. Okay. Yeah. Oh wait. This is it really now. Okay. And then we don't have to, well, actually we do pointer, we could we pointer cast it? Yeah, I guess we do the same thing. I'm just not sure about how much space you actually need, but I guess we could extend it if we want as well. Okay. It's a little bit finicky, but I don't know if this is like gonna work in the long run. Right, so now we don't need these. But we need, okay, so wait, this would return, no, actually this would now return the generic iterator of a U. And data would basically be, let's see, so I think there's like a 2 bytes or something, yeah. Where the inner is IT, there we go. Okay, and then we also need, oh, here we go. So we actually need 24. Interesting. But it's good that it tells us and that it knows about it. So great. That gives me a little bit of hope. Let's see. Then we also need the V table. It's gonna be like this, right? Okay, So let's just extend it to 24, I guess. Also, hopefully you don't get... Wait, now it needs 32. Oh. Right. So it basically it includes itself a little bit here. So we have the like, because this also has the data. So you can't really you can't really have another generic iterator here. It has to be like a pointer then. Right. Yeah. But if you have a pointer, then this whole thing doesn't work. So this should work for the slice iterator. Like iterators that doesn't have a pointer to another iterator should work. Or I mean the yeah, that doesn't need that. So basically higher order iterators like map here will not work, I guess. Like this. Because I don't want it to be a pointer. Unless we build it in. We build in the ability to refer to another iterator. In here. Like we have data for our own iterator, and then we have like for higher order iterators we have no, this doesn't work. Or wait, yeah, because then it's gonna refer to itself. Also, what would the type be? I don't know. Well, I guess it would be like... No, that's the same problem, because then that iterator will also have like a reference to another iterator. Well, I guess it could be a nullable. Hello, Neurosite. How's it going? Welcome. But okay, so what if we add like other nullable, and this is a... No, it's the same problem, I think. It's the same problem. The issue is that we can't really have a pointer to the other iterator in map, because then we have the same problem. We have to do this solution instead in that case, I think, because we can't store the iterator in the map iterator. So if we try it, like if we put pointer here, but then we have to put a pointer, then that has to be mutable. Right. Type of slice. Yeah, okay, so get rid of you. Oh yeah, and now we get a generic iterator. Right, so now these functions need to be, wait, they are changed. Why does it expect? Oh, I forgot to change here. There we go. I know you've done lots of stuff with async in Flow. Flow. Oh, which Flow are you talking about? Are you talking about the JavaScript thing? Flow control is my Zig text editor. Aha, okay. Sorry. Oh, cool. Flow control. Okay, now the errors are gone. Let's go where we use it. So yeah, so now we don't have like this .it. We do instead, we just say iterator. Well, let's do this. Slice. Right, so that returns a generic. But now we actually need a, okay, this is the problem here. So if we just pass this, it's gonna complain because it's gonna be a const. Yeah. So we still need to create it over here. But I guess it's better. I guess this is like one step better, and you are also like sort of protected against doing the wrong thing here. And so you could do this and pass it in, but you don't have to call .iterator anymore. Yeah, that's a lot better. And then here we actually don't need to do this. We can say var iterator is this directly. So now this is a generic iterator. Okay, well that's a little bit better. It removed like 2 lines of code, or 1, or yeah. Flow's async stuff is all actor based, no iterators anywhere. Okay, I've never actually. Well, I have done some event flow stuff, like event sourcing with CQRS and stuff like that. That's kind of almost. I don't know. I don't think I've done any like what you call like actor pattern. We've at least kicked the problem of nesting down the road. Yeah. Well, I mean, now we don't. At least we don't have to call .it here. We still need to create this separately when we're dealing with higher order iterators. We still have the problem of nesting higher order iterators, but at least we got rid of a little bit. Although there is a trade-off here, where the data can only be like 24 bytes. I guess you could increase it, but I wonder what happens if we change it back to 16 now. Will that be an error now? Okay, so it's apparently 24 when you have. Oh right, this is not only a pointer, right? This is a pointer and a U size. So it's a pointer and 2 U sizes. That is a U size in. I'm not sure what size that is actually. Is it's. I guess it has to be 32 maybe. 232s and 164. No, it has to be 364s. Yeah. U size is 16 bytes. What about the slice? Because that has a length and a pointer. Wait, does this work? So U size is 8. So so it's 3. So this is 16 and this is 8. So that's 24. Yeah. And the map, but the map though, the map is like this is only 1 pointer. So that doesn't complain. Okay. It's nice that it doesn't complain if it's like less. I guess it's part of 2 bytes here. Maybe. I don't know. 2 bytes. No, this just returns. Actual size. It's when we assign it. So you can assign it this to an array with less. Okay. I'm not sure 2 bytes with a slice is well defined, since slice don't have well defined memory layout. All right. Yeah, I'm a bit scared to use this, but I mean, shouldn't it be the same? At least, like when it's compiled. I don't know. Like it doesn't have to be the same across several compilations. As long as it's the same in one executable, like it should work, right? I don't know. I might also ditch this entire thing, because I might, instead of doing this, write like a snippet or something that you could sort of generate a new iterator easily. So you would say, like I said last stream, like you just write an iterator on the spot. The problem there though is like, well, there's not really a problem with that. It's just that it's a bit annoying. But yeah, I think I'll probably ditch this and go with just writing the iterators. Because right now I basically have these things. The response. Wait, where are they still here? That should be like. Oh yeah, we have to pass in that. There we go. Yeah, so for example here, we're allocating this list, but we could go all the way back here. Here's where the list comes from. That's also like allocated. We could go all the way back here and return an iterator instead. And then we map that iterator here. And we send in the mapped iterator into this. Yeah, I do like that. I guess one really nice thing about the generic iterators is that you can define them like this. Because if you... Otherwise, you would have to say like any type. And you would have to assume that next and reset exists. Right? I guess you could sort of have one last step where you like realize the iterator. I don't know. But then you couldn't really compose them though. Because, yeah. Well, I was thinking like if you have like intermediate steps and then at the end you realize the iterator and then you send it into the place that's actually going to use it. But then I don't know. Okay. And I mean, I guess this works a little bit better. Okay. Well, anyway, enough about the iterators. Right now, I am fixing the dialogue thing. So we made some changes to handle the on and thing. So this should now be handled. Wait, are we handling it in? We're handling it in choose response, so it should actually be handled here as well. Yes. Okay. Right. So I'm gonna try and run here. We have a... Right, so this is actually a lot nicer now. We could even maybe... No, we need to say that. I mean, I really do like it. The iterator stuff, because it yeah, as we said yesterday, like it does prevent you, or I mean it does make it so that you don't have to do allocations. What's going on here? Okay, that needs to be mutable. Makes sense. Okay, now this is different here. So, okay, I didn't get this compilation error before. How would we fix this though? Do we have to pad the struct? Yeah, this is very ugly. Okay, so I have to choose a response here for it to trigger the on end. Okay, there we go. So now he says only hi. That means the on end was actually triggered. And if we go back and forth, we can go and gather the gems, see if everything still works here. No. Okay, so he resets back. Okay, but that's another issue then. Oh, wait. Where? But no. Okay, but this it's weird with the padding here. But yeah. I think this is a little bit better. As from a I'd rather have quirkiness in the implementation of these things than to have to ease the usage of them. So right, so right. Oh, okay, I see. We have to add a thing here, so we have to grab the. We're not storing this in the sort of persistent state, so we have to grab the container of the state, and we have to set this to. Oh, we have to like grab the NPC component as well. And the option key is the new option key is this. Yeah. There we go. Now it should be. Oh yeah, we also need it here. Now it should be persisted between the scene transitions there. Might do ++ with an undefined array map iterator. Oh, I see. Well, I'm not sure if that. Oh yeah, I need to talk with this guy. I'm not sure how that will also like. How will that happen with the like the memory layout and stuff? Oh, we got a crash. Huh. Where's the crash? Dialogues. What? Appending it after 2 bytes seems like it would be fine, right? Like here. Like this. Can you still do this? So it works, but now I think this, like, what about when casting now? Because now I feel like this could. All right, as 16 U8 undefined. Yeah, yeah, that's probably better. But I'm not sure if this will work 100% of the time. I don't know, maybe it will, because you're adding it to the end, but then it's like, okay. I don't know. I feel like it's safer to add it here. I guess we can try it. Although it did crash. So it seems to work though. Come on. Oh yeah, and so did it crash like after? Yeah, it crashed when you try to talk with him again. Like the reason why I think it's might not work is because we're kind of changing. I don't know. It feels like it's safer to put the padding in the struct itself, because then Zig knows about the padding, you know. Yeah. Well, this is like, okay, you're just adding it in the end, but then Sig might assume some other stuff about it or something. I don't know. I don't know if it's a problem with the endians or if whatever problem is gonna be. But now Sig knows about it, so we can be sure that we will get stuff at the correct place. Yeah, exactly. The way you suggested will assume the memory layout. So I think this is safer. It isn't nice, but it's like, yeah. This whole iterator system isn't perfect either. But why do we get a crash here? I'm not sure, actually. I mean, I can see here that we get to this part. We actually get here, so it didn't find the option key here, which is weird because this struct is defined by to have all the keys. So it works like this. This struct is I made this enum to struct, which I did. I know that I saw somewhere that there is a thing that does the exact same thing in the standard library, but I couldn't find it before. But I did make my own some time ago. So this basically takes an enum and a value type, and it basically makes a struct that has all the enums as fields, and the types of them will be its value. Oh, there's enums. I have actually didn't know that. Enum field struct. Yeah, here we go. Oh, you can even set default thing. Yeah, okay, yeah. So this should be like the same thing. Probably use that instead. Default is null. Okay, so if you've set default, do you still have to... Let's see. Now it should complain, yes. But if you set a default... Right, and then you remove. Will it complain now? No, it won't complain. So I don't like that. I don't want the default. Be careful with the default there. As null is different from just null. Just null means no default value, while the other means null default value. Okay. Well, I don't want a default value. So this should be good. Because otherwise you mean that I would put a nullable here and then say as option. That's good to know. Like this. But I actually want it to be null. So, or I mean, I actually don't want a default value. Okay, but anyway, so it takes all this and makes a struct with all the types or dialog options. And so it's curious to me that it complains that it doesn't find the field because we're passing in the enum value. Like, let's see. Yeah, this is an enum value. And I guess technically enum's values could be, I guess, wrong. But it shouldn't be here. I'm not setting anything to something that it shouldn't be. Starting dialog state. So that's what we did here. We set that to this, which is also a dialog option key, which comes from this, which is set here to Elder Star 2, which is here. So I don't understand why it's wrong or why it doesn't find it, but let's check the code here. So we're inline for all the fields in dialog options. I guess we could inline like we could inline for the, actually isn't this, we could do a switch on key and do inline else, and we get the tag out. This is now comp time, and then we can return tag name, right, of t. Is that's basically the same thing, right? I'm doing some weird stuff here. If key is equal to, okay, yeah, I don't know. I think this should work, right? I'm basically passing in the key, and then I just want to get the field that corresponds to that key. Yeah. You learn a little bit more every day with Zig. Okay, so now, no, it crashes again. Okay. So I'm just gonna log this out, get option like ID key. Who are you? Well, it might not be that one because it's saying invalid enum value here. Okay, is this some memory issues? Inline else is very nice. Yes. It took a while for me to actually get there when I wanted to have like comp time known tags. But once you get it, then it's really nice. I really like the tag unions in Zig. But is it this one that is weird? Yeah. With tagged units, so we have the first capture is the value, and the second is the content. Yeah, I know. There was some issue I had with which I solved now, but it was at first it was tough for me to understand. Okay, how can I get this comp time? How can I get a tag to be comp time? I was trying with all different sorts of things, but I think you have to do like an inline else or in a switch, or you could also do, because first I was trying to do like how to do it in standard meta, library where they like loop through with a inline 4, I think. But inline else works really well. And then you can do like inline 4 and then you match the tag name with the string and stuff. I don't know. I was trying to do all weird kind of things. But this... Okay, this might be an issue with the iterator, maybe. The iterator might be spooking us here. Because we are in here. It's accepting the response. We get the responses. Well, that's actually just a thing there. So this is actually not an iterator though. Wait, are we freeing it somewhere or? Now here we're allocating the option infos. They are here and then we allocate them when we defer it. Here we don't allocate anything. Okay. And this one allocates, well, it calls this, which allocates here. Right. I'm just going through, making sure we allocate everything here. So response, options length, going through all options, we're setting their responses. Isn't this supposed to be a mutable? I guess it doesn't really need to be if it's a pointer. I don't know. It feels weird that you say const responses and then you can still like change the. I guess it's like a const pointer to some point, like something that is mutable. Wait. This might be the issue. No, we're copying it. We're copying it. The pointer value is const, yeah. I don't know, my brain just thinks sometimes that, oh, it's const, so you can't change it. So you can't change the content or anything. But that's not the case. No, this just copies the thing. So it's like, I think Am I even looking at the wrong or correct place? Like, I don't understand. This doesn't make any sense. Oh wait, is it because this is an array? No, but it's still. It's like a pointer to a constant slice, so it should just stay in, like, I don't know, read-only memory or something, right? Because we're defining it like here somewhere. No, where is it? Here. This thing. So when you, so this is one thing that I don't really understand. It's like when you have, well, this is a slice. So, but when you have an array, maybe this is well, when you have an array and you when you have a struct that has an array in it. So let's say you have this. Right? And then you make okay, let's just do 8. Okay. And then you say B is equal to A. Like, this doesn't work, right? It's not gonna copy the array. Yeah, this one is comp time known, yeah. So it's like we know the value of that, but it should also be stored like in some sort of, I don't know, read memory variable or something, or not variable, read only memory that you then can also access and use as a pointer, you know. But it's pointing to like a static memory part. But this thing, I tried, because at the start when I first tried Zig, I made stuff with arrays instead of slices because I was trying to avoid allocating stuff. Yeah, B is a copy, but I think it doesn't really properly copy A because it has an array. I'm not sure, actually. Well, never mind. I need to focus on this problem here. Why? When does it like not? When is okay? Let's just go backwards, I guess. I think we can reload this. So what if we could make enum, so int from enum. We must see like a bogus Switch on corrupt value. Okay, but it has to be something somewhere along the line that there's some error, memory error here. I've never seen this. Zig arrays are always values, not pointers of as far as I know. You can have array pointers too, but Zig doesn't switch between them. No, I meant just having a struct with an array in it. Just a naked array or whatever you call it. Like no pointer, just an array. And then you copy that struct. So you have a struct. You have a value of that type, the struct type, and then you copy that. And I am printing out inframino here. It says 10 as the last thing. I'm not sure that doesn't feel like the. I mean, do we have 10? I guess we can check how many we have. 1, 2, 3, 4, 5, 6, 7, 8, 9. No, we don't have 10. And yeah, I didn't do it before. I changed it now, but then it says switch on corrupt value. Well, 10 is not valid, so we know that. But how does it? Why is it 10? Is the question. So now it goes through and it does this one, but it's like switching on. I guess it's checks if it's one of the values, and then it panics because it's not. So so likely 0xAA for the full byte. All right. I mean, it could still be the iterator. It could still be that the iterators are doing some weird stuff. So let's try and replace those. Where am I? Or maybe not. Because we're going in here. And we don't use an iterator. Okay, yeah. Because what I was thinking, it might have something to do with these ones. Like we, because so you choose the dialogue. When a dialogue's done, we call, like when the starting dialogue is done and you go into other options, we call choose handle response here, and we call handle on end, which will in turn go through things in here, which is this one, and we get the slice out here. We handle the action. The action is set starting dialogue or change starting dialogue. Then we get a whole bunch of stuff here, and we have this, which comes from here, which comes from the action, which should be like in read-only. It should be from like read-only memory, I guess. So it shouldn't be. Also, this worked. Like this part actually did work. If we just remove this and run now, it's not gonna crash. Well, it didn't before anyway. Yeah, so now we get the new starting dialogue. So this part is the thing that doesn't work. Oh, I'm stupid. I'm stupid. Oh. I never finished this. Okay. I mean, it doesn't matter if we found existing or not. Okay. So it didn't, like, okay. So the issue here, like, we only set the value if we found an existing. If we didn't find an existing, then it's gonna populate it with whatever is in there, I guess. Which, yeah. Okay. Okay. Always finish that. Those functions. Oh yeah, there was a lot of headache for that small error there. There we go. Oh, but wait. Oh, I see. I can't accept out of this part. We should be getting in here and right, this is different now. Okay, yeah. Yeah, I think that should be good. Alright. There we go. Wait, this is also weird. I'm going in here. I don't choose response. And then he says the response. Oh, we don't draw it. Yeah, the draw thing. Okay, this should also be changed. This should be like if either we are starting dialogue and we're done, or yeah. Okay. Now let's just try the persistence. Oops, I should add just, you know, a oops. Let's actually go over here instead. I should add a debug thing to add a whole bunch of gems. I guess I could just set the gems to be 5. Have you tried using the x86 backend for a game? Should build real fast. I've not tried it. I guess I'm using like the default. Should the quest, should it like block down here? Like we don't see, I guess maybe it should be in another place. I don't know. Maybe it should like move depending on where the player is. Okay, there we go. Now you can see now it says just hi. That's the second start, so that means the persistence works between scene transitions now. There we go. Okay, nice. Yeah. It's I think also I use vectors pretty heavily in the physics engine, and I'm not sure. I think they said something about the vectors not being fully like implemented or something. Yeah, I mean, it would be really nice with faster compilation times. Let's see. So how would you enable that? Interesting. I think yeah, this is the vector stuff, right? Or right, like the yeah, doesn't support. Yeah. Yeah. You'll have to wait until it's done. All right. Where did I put this? I think maybe I did it wrong. I'm gonna fix this thing. Monster death animation should be static. Velocity set to 0. Should be pretty easy to fix. I think basically anything that dies is gonna do that. Wait, where's the... Oh, it's in animations. Yeah, alright. This is like the only place I use these sort of event listeners from the, like in the ECS system. Like whenever a death component is added, this is called. Okay, well I guess we could use this then as well. Let's get the body. So we set it to static. That will make... I don't remember. Let's just do it. And then we set the velocity to 0. And we also add no gravity. I guess, well, yeah, okay. I guess we can go over here. Yeah. So we know it works because there's like a knockback. Let's try and see. No. I was trying to see if I can knock or kill while it's in the air. But we can go to the other place. Here, or wait. Well, I guess we can start here. Oh, we got a crash. Interesting. Component storage. Oh, because it already had it. Okay. So I guess we'll do if. So add, or I guess add or replace. In that case, yeah. So it basically crashes if. Yeah, if the component's already added. Right. And here we have the flying guy. So before you could very visibly see that there was knockback on these guys, and when they died, they the death animation played like when they were hit like that. But now it is. The death animation stays still in the air, basically. Okay, great. Oh yeah, I forgot that we had this. Wait, did we have like leaks or anything? No. Okay. That was that. What else can we do here? Well, I would like to continue work on like the demo area, but it's not gonna be like too much programming going on in that case. I guess one thing that we could do is like save stuff. We do have dialogue states. We do have this. We're just not storing it anywhere in any file or anything. But technically, we could just store we have array like the hash maps. We could just store those and load them in. And I guess we do have inventory equipment. No, and quests. Yeah, quests. Quests also has like quests. Well, this is like a quest description, and then we have quests. We have, this is basically the same thing as dialogues. Except this for quests. And here's the state. Or the state for one quest. Yeah. So we store if it's accepted, completed, and the progress. Right. So all this could be stored like technically in yeah, this is just a string in a thing. Here's the array hash map for the states. That could also just be stored in a file together with everything else. I guess we could just make it like a save file struct and save that. And then we create it, you just pass in everything from here. I don't know, maybe this is something that we should do later. I mean, it's still gonna be the same functionality, right? Save. Save. Yeah. And so we have basically we have quests, quest states. States. Okay, so basically we just copy the type from quest states. And we can do the same thing here. have the player component. We don't need to save that. What we need is, I guess, the inventory. Let's do this. We're probably maybe gonna have like a serialized version or something, but let's do it like this for now. Field type. Oh. But then you pass in a name. I see, it's a little bit different. Because here you pass in a string. Com times string. Here you pass in like an enum thing. I mean, I guess it's not that much big of a difference. I think I'll actually stick with this one. This actually just uses field type. Okay. We sort of get like, well, we don't really get auto completion here because the LSP doesn't provide it, but we could technically you could. Well, technically you could do it with strings as well, but anyway. What else do we want to have? Menu state now. Yeah, I mean, yeah, I think that's it. I guess maybe health, like max health. Max health. Max health. Yeah, just store max health because because why? Because yeah, we can just say that you always restore the health when you save or something like that. Although we probably want to have like, you know, this feature where it's sort of, well, it's gonna be, I don't really know actually. We'll probably have like Hollow Knight style. You have a bunch of, or you know, Super Metroid. You have a bunch of saves, places, save spots, and I think Super Metroid actually restores health on those. Probably gonna have like that. You can always change it. So okay, so there will be a save. Now I want to try storing this maybe as a binary. I haven't actually tried that. probably need like a version as well. Standard IO writer write struct, reader read struct. Okay. Let's just say we have a file name, and oops, we say like well, we don't do that. Right, so we open the file. Yeah, let's just assume it's absolute. And we get a writer. I mean, I guess. No, I want to have a write struct, read struct. That doesn't exist. Yes, it does. I don't know why I didn't see it. Write struct itself. Okay. Is that it? And then we have load. Actually, let's produce a save. Like this. Okay, seems pretty straightforward. All right, and then all right, but then you know we don't have a way to. We don't have like a menu or anything for it. So what we're gonna do is we're just gonna load up a default save file. Also, the game needs a way to load a save as well. I guess what we do want to have is like which scene are we in, or like where are we? Well, let's actually we'll just always start at the village or something. And for now. I guess technically we could just add a save file name here or something. I don't know. It's not. This is just gonna be like. So initiate level, doing all this crap. So I think before this we will do. Okay, I'm gonna think about it a little bit. I just need to be like 2 minutes. Be right back. A question there. You have no pointers in the struct. Well, the struct was it was. I guess they could technically be pointers. It's a. I was thinking like the struct should be just a very temporary struct that just saves it. But they could be probably pointers, yeah. BRB. New coffee. Okay. Right. Okay. So. Yeah, I'm wondering if some of these things can be basically loaded before everything else, actually. At this point, we have basically all the sort of containers and stuff registered in our. So the way it works, I can show you here. We're using a library called Zig ECS, which has a thing called a registry. Now the registry supports both like mapping from entity IDs to components, but it also supports singletons as well. So I just read your messages. Just checking that you aren't holding onto invalid pointer by saving into a file. Oh yeah. So the idea was just I think I basically want to create that at the instant I want to save it, and then when you load it, it's basically the same thing. You just load it and use it directly, I guess, and then do away with it once it's done. So yeah, but the registry has singletons, which is just a one-off any struct you could put in there, and then you can get it out, sort of like a dependency action system, but it's only like one scope for the entire program. But we are using that to store all kinds of things. So, for example, we can grab out the dialog container like this. So now we have the dialog container, which should be available at this point in time. And so let's just make a temporary function here, temporary load save function that we call, and we need the registry, or I guess, well, yeah, let's do game. That's fine. Okay. So now we have that. So let's load the save. I wonder how it deals with the array stuff. The hash, like this says it's gonna pop, you're gonna get out the same struct that you write. But how does that work for because when you're serializing these as JSON, you can do it in sort of different ways. You can either allocate everything in a... You basically have to have an allocator, and you allocate... You could allocate in an arena, or you could allocate not using an arena, basically. But here it seems like it just returns the type itself. I guess we'll find out. So let's load save file. Save. And if something goes wrong, we log could not load save file, and we can return serializing arrays. Well, what I'm thinking is here, like these things are fully serializable, like they're just simple structs. But the quests here, it's actually like an array hash map. So I was just thinking, if it's able to actually do that. What is this? Self-adding? You need to deserialize that hash map manually. Right. Well, this just puts as bytes. I mean, I guess it would sort of work because we're not gonna use... Okay, so how we could use it, I think, is this. You load... It's basically gonna populate things here. Hopefully. Well, how does it deal with pointers? No, that doesn't work. Because it can't just write it as bytes. You can't write a pointer as a byte. That doesn't work. Yeah, this doesn't work. Okay. So it wasn't as easy as I thought. Because I think what's gonna happen here is gonna take the pointer and write it as a byte. Like it write the actual pointer itself, not the content of the pointer. So it won't work with slices and stuff. I mean, I guess we could write it as a... We could serialize it with JSON. I guess. But I just wanted to try if we could write it as a struct. So basically, or to write it as a binary. So basically we need like serializable versions of the hash maps in order to do that. So it's gonna be these 3 hash maps. We could also maybe... Could you do it like this? You write... First we write... the version. Alright, so the point is here, if we write a bunch of these stuff, then we can read it in the same manner. So we're gonna get a version. I think big is the endian where you have big first, right? So go from big to... So basically, index 0 will be the biggest number. And then you go down, which should be... the best way to store it, right? I think. I don't know. Maybe it doesn't really matter that much. It's just a U size anyway, so... version, and then... return and save. So basically something like this. Version is version, and so on. And so here we write, well, we could just write the max health. Maybe it's better to use this. No, that was U32. Okay, I'm just gonna try. Okay, let's just try this. But then I also want to store maybe the dialogue states. We could store. Okay, we could do this. We could store all the sort of easily serializable things in one place. So we could have like I guess I don't know what to call it. These are simple types, and then these are like not simple types. So now we should just be able to say write. Actually, the version should be different though. The version should be like dot big. Yeah, that's true. Now actually, but now we have to. It would be. Okay, there we go. That worked. I didn't get the LSP working there. Okay, so we get the version. I mean, the versioning it doesn't really matter that much right now, but and then potentially now we can just check the version. What is the version? Version is something else. Okay, then we have to handle that version. Something like this. And then we're gonna read in, I don't really know what to call this. But now we can use write struct instead, so I guess it's safer to use endian. Okay, it will work cross operate systems maybe. Yeah, it would. You could write big here directly. Oh, now it works. I didn't see it before, but when I have the same for everything, I think. So I'm just storing it like that. Okay. So now we write primitives. Well, the value. Okay, so we don't have to. So we write that. Right. And here we can read it. And then we can store it here. Primitives equals primitives. Okay. I guess non-pointers is really what we have here. Like non-pointers. Arrays could still be technically there, but I don't have arrays. That's also like the trouble that I got into using arrays in Zig made me not use them at all, basically. The only place where we actually use arrays are from a library that returns an array, like a UUID. Oh, and the iterator iterator stuff that we did. I mean, what that was I was talking about before, like copying struct, like copying. So I think basically what I had was, let's say we have a struct. A is an array with 16 U8s or something like this. Now we just set it to, you could do this 1/16, okay? And then you have a function that returns an A. And so function create A, return A. Yeah, I guess we can just return A. But then sometimes I would get like garbage stuff in the array when doing this type of thing. So I just assumed that copying a struct that has an array in it will just not work sometimes. Like copying by value. I have to try it out sometime and read up a bit on it. But I had a bunch of trouble because the first time I tried Zig, I wanted to avoid using allocators at all costs. So I had a bunch of arrays, like strings I kept in arrays with like a maximum length and stuff. But then I got so much like memory errors, and I assumed that it was because when you copy a value that has an array, it doesn't really copy the array. So normally if you say, let's say const A equals A, const B equals A. So at this point, B copies everything in A, which basically it's gonna go through each field and copy it one by one. But if it's an array, I'm not sure if it actually does that. Not sure, you might be seeing PRO somewhere where secretly passes big structs and arrays, I think too, by pointing one once. Big arrays. Yeah. So I just avoid arrays. Unless I like fully know that, okay, there's no issue right here to use it. I just use slices instead and allocate them. Oh hey, copying structs with arrays is fine. Structs with slices are more complicated because slices are just pointers. Okay. I mean, yeah, if you're aware that you're like if you know that the pointer, that the slice is, like I'm using it all the time. If I know that the pointer is safe to copy, I will do that. But the erase, I just got the feeling that it didn't properly like copy it every time. I don't know. Maybe I was just using it wrong and I got the wrong impression. Okay, so now the issue remains here. So we have the primitives and stuff here, or then I guess non-pointery stuff. Now all of these probably they should be backed by pointers. So we should have maybe one way of turning these hash maps into some sort of serializable format. We could just write them, I guess we could. So let's just try the quests, for example. So we'll go through, they should be hash maps. Okay, of course I don't get the... I think it's like val.values. Let's get the integer here. Okay, so we need the key, right? This is an array hash map. Well, this is really this part here. Okay, anyway, so now we can do try write. Well, actually, we want to write the length first, I guess. So this is gonna be the length. Be like, is it count? I think. And then just a little bit cleaner, yeah. All right, and then we write first the key. So what would that be? Write maybe. Well, the key is. I mean, it depends on the type of the key. All our keys are enums except for one, which is a string. So that's bad. Could we do this? Could we say, if type of key is a string, then we do something else. We do What is your serialization format? I don't know what you mean. I'm just trying to write a binary save file here. And I'm going through, so everything that I deem is able to just be copied as a byte, I write here in this primitive. So basically just integers and simple things. We don't see the type here really, because this is an integer, this is a struct with a bunch of integers basically. But then these things are like array hash maps. So I'm trying to serialize them. So first I write the length. And then the things down here, the keys. The key is, well, if it's a string, we want to write it. And so this should also, everything here should happen at in the same order. So it doesn't matter if, you know, we're looking at the key here. It's all going to be in the same order. I would recommend a well-known binary format like CBOR or message pack. That way you can get tools for free to view your files. Also can convert it. Okay, cool. Yeah, I haven't. You know, I'm a very noob game developer, so this is basically my first project that I'm like seriously trying to get complete. So yeah, that's a really nice tip. Thank you. C4 concise binary object representation. Right. So which one would you recommend? CBOR? Okay. Yeah, this would be actually a good. Oh, is that your own? Okay. Oh, for Zig. Oh, I see. The Sig version of CBOR, or yeah. So I guess the standard is very known. It's not your own standard. Internet Standard RFC. Okay. Cool. So how does it work? Do I really want to go in here? Yeah. Okay, anyway, I think, okay, so I can just use this and do it. Yeah, so basically, to your question before, there's no format. That was the answer to your question. Okay. So what is it binary? I guess it is. It said binary somewhere here. Yeah, concise binary. That's good. That feels like a good thing. So error. Wait, no, this is top level here. Yeah. Write any type. Writer. Okay, and value. Okay, cool. Wait, value U8. Oh, so that's like write 1 byte. CBOR is basically a binary representation of JSON. Okay, cool. Well, I have heard of BSON, but maybe it's a bit different. Maybe it's the same. I don't know. Here you can write a value with type. Oh, okay, so you can write, you like embed the type here as well. Or is it your own like enum or something? I don't know. Non-standardized CBOR, okay. Array header. So is there a function that you can just pass in any struct or any type? Where you can pass in an array. Write value. So what about pointers? That's okay. So we're dereferencing the pointers. Yeah. So I guess so. I guess you would have to have like built-in support for array hash maps, right, to make it work correctly here. Because there's the same issue with the JSON parser, the JSON standard library. Because these are, well, it's basically just typing for here. Struct, so okay, you can have your own function just like JSON stringify. And we're checking for tuples, okay. Right. Okay. Cool. Wait, isn't there like a version, like Zig version nowadays? You could have Zig version something. Yes, you would have to add a hash map support or just write a function of serialized hash map. Yeah, okay. As a map or array of key value pairs. Ah. Okay, nice. Very nice. And then once you have it in CBOR, you can use a bunch of tools and stuff to read it and stuff. Okay, yeah, cool. Well, that will probably help with like debugging if something is weird with the saves. That's, okay. All right, so let's try it. Is it 0.14 or does it work with 0.14? Because that's what I'm using. Oh. Right. Here's an example of function serializes generic SIG structures. Alright, read CBOR config, okay. So it's like read CBOR with a config. Is that how I'm supposed to understand the function? Because at first I thought that it was reading some sort of config file. But I think it's like read CBOR with more config, or because you can pass in anything here, any type. The conf is anything. CBOR mesh string. This is Because the function flow uses these here as a conflict. Oh, okay, okay. Wait, where is the definition? Okay, I was just thinking because this is set to undefined. Okay, no man, I'm just gonna go through it. Fields. So first we're matching it. Also, we're populating it. Okay, and I understood wrong. I think at least. Right. So we have an iterator, and then field name, and we're matching. Something. Matching will set the value only if the next value in the seaboard stream is of that matching type. Okay, okay. So you're iterating through basically the, well, I guess in JSON it will be tokens, but here it's like values. Expected values in the seaboard format. Well, I guess it's the same for JSON as well. Okay. Right, and it's a string, so we're gonna match a string here. And so we're gonna get a string. And then we're looking for the field here. Right, so we're matching the string with the... we're looking for include files. Oh, can you include files in this format? Interesting. Include files? Or is it just... wait. Yeah, we're looking for the include files field. And then we're checking if the field, if the name that we read here is the same. It's a flow feature. Yeah. Okay, so it's a thing that exists in the struct, I guess, of this type here. Okay. So you have it like generic because you might have like different versions, I guess. Or something. It's not really that... I mean, I kind of get it. So do you have to use these like match? I guess you have to use these things. This really reminds me of the JSON library, like the JSON parse stuff. Could also use meta string to enum. Oh, you mean here? We're sitting here code reviewing it. Okay, but let's see. So this. Oh yeah, I have to. Okay, what is the module called? Wait, where am I? Seaport. Great. There we go. Okay, tests. Alright. This test serializes a map. Okay. Right. So. We're writing a header, map header, okay. So is that a thing that exists? Okay, right, okay, cool. So we can just use that. And then we write a bunch of values. But here you have to like know that, okay, first the key and then... Okay, so I guess it's like embedding the string type and everything in when doing this. And key series and value series, okay. Right, because, okay, I guess Seaboard maybe doesn't have the concept of or like maps and stuff. Okay, get written. Okay, so you can do. So is this also? Okay, so you have a 2JSON. That's cool. So you can basically sort of debug it as well. In that way, if you want. And here you say, oh, that's the. Is that the bytes here? Yeah. Into the string. Okay. For most structures, I would just write arrays of values and rely on the context to know what kind of object it is. Save a lot of space and not write keys. Yeah. I mean, the issue is we need to know the key is important because it's the key, like here we have quest key. It's basically an enum here. I mean, I guess this would correspond to like 0 and 1 technically. So anything that is an enum could basically be just put as an array, I guess. The one thing that we do have is the NPC key, which is not an enum, it's actually just a string. However, we should probably put that in an enum as well, because it doesn't make sense. I mean, we're gonna know which NPCs are there. We're not gonna like spawn random NPCs in the game. It's gonna be like statically known. So we should probably, I should probably change that. If it's a closed set of keys, you don't really need to write them to your binary format, but if you're not worried about space, it's easier to debug if you have the keys. That's true, that's true. I mean, I could just infer the key. Well, if I mean, I guess it depends on which tool I'm using to look at it. I mean, it's not gonna be, well, it depends. Maybe it's like during debug you could have that, I don't know, version or something. But then during like if release mode you could switch the type to something else. If it's an issue. I don't think it's gonna be that much of an issue. I would write keys and values for easier development and worry about space later. Yeah. That is wise. Okay, so let's see. We have our seaboard here. So let's write should be easier than read. Possibly. So we have our writer here. Let's move this out of the way. Alright, so we have seaboard. Do we need to... We could just use the functions as is. Alright, so let's see. We have write. Yeah. So it's just using like the writer. So we could write... Let's write I guess a JSON value. What's this? Oh, that if you have like a JSON, like the standard format, or I mean standard JSON value. Is that what that is? Yeah, this is the standard JSON library. Yeah. Okay, so write value and by the way, Seaboard tool is a nice command line tool for viewing Seaboard files as JSON. Okay, cool. Yeah, thanks for the tip. I think I'll check it out. Can I? Does it exist somewhere? I don't know. You can write zig JSON value structs directly to Seaboard. Okay, yeah, cool. So we'll write the version. Okay, and that's it. Don't have to do anything else. I guess we'll try as well. Okay. And then we can write. So value basically can handle anything. So we'll basically do the same thing. We'll write our easily serializable things first. And then we want to write our quests here, which is an array hash map basically. So writing a map header, and I think it's gonna be the count, a number of things, and then yeah, and then we loop through. Yeah, we basically do what we did here, but we're using like the Seaboard format or whatever instead. Okay. And we don't need to worry about that because we can just use write value, right? Or key first, and then value. So if we would do an array instead, it would be like array header. Oh, you can just write array directly. Will that take care of everything? Like array header, yeah. Okay. Nice. I'm just gonna try something here. This should be the same for each type of map, right? So count well, I guess it's a array map. Values and keys. Key value. We're not actually calling this function, so I don't know how much like compilation stuff we get from it. I'm just gonna add that real quick here. Let's go to init. Well, actually, if it's pub, it should compile even if you don't use it. I'm never quite sure about it, to be honest. I just know that there's some stuff that shows up after you're actually using it. Okay, so now we need to create a save from our current game, which we should be able to do. We need those, we need the player components, we need the player, which is a game player. Alright, now the save is, let's just do this. Oh yeah, we need just health component, max health. The inventory is player inventory. The quests is quest container dot quests or states. So here we're just copying the thing, but I think that's fine actually. Because the maps should be copyable. Like they refer to the same map. Okay. And then we call save. And we catch. Oh, you can't have the... Okay. Save. And okay. You want a thing, so... Save file is gonna be yeah, and yeah, okay. Now I get this error here. I get the error. So, oh wait. Of course I get the error because this is not a save. Wait, I still get... I get the error. Oh, no. Shouldn't this work? Is it because it's an error? Is it because it's an error? Or... Oh, okay. Wah, wah. Alright. Okay, but now we are calling save. What's happening here? Oh, I see. Oh man. Okay, let's just store it here, I guess. Yeah, we'll free it from here. I don't care. Temp save file. And no. Okay. It's complaining about the Seaboard module. for some reason. Do I have to... Okay, I'm just gonna try a restart, maybe. Okay. Let's see, missing struct field quests. Yeah. Okay, yeah, the load, we haven't done the load yet. The save should be fine. Let's just return wait, what's this? F64 type. Tag type. Oh wait, that's right. Maybe it's because... No? I don't know, actually. Also, we reached unreachable code here. Maybe. Which commit did you reference? You might need Seaboard commit. Ah, okay. Well, I just took master. How do you do it? Is it at? Or is it hash or at? I don't know. 4B73. Does that work? Okay, I'll look for... EA4B73. Copy the hash. There we go. Yeah, thanks, I got it. There we go. Now I guess if we save, it's gonna download it. And then we'll restart. Save. Check the errors. No errors. Okay, so let's see if it's gonna save anything here. You should actually save the actual state. Could you link the Seaboard tool thing? Because I'm finding like a million different Seaboard tools. No, I still get this. I think this is something else then. Is it from the maps? Yeah. Also, I'm not sure what this is. Where this comes from. Let's do a test run, test compile. This comes from a search, the layout. Ah, okay. in load. Oh, I'm trying to read things here. So this doesn't work? If you don't have Seaboard 2, you can place your Seaboard as hex. Oh, okay, cool. Yeah, I was trying to find if I could just install one of the tools, but I was just... There's like a lot of different... tools. Is it Seaborg? This one? This is Seaborg 2. And I see Cabal here. That's Haskell, right? Yeah, Hackage. Package might be Seaborg on this, yeah, okay. Well, I don't want to use Cabal. I'm not that good with this, but I guess whoa. Okay, I mean, I don't think I have it, so why do I need like serialize? Seaboard 2 from Python, okay. I'll try this and we'll see. Okay, now we're getting something we should. Okay, I think I'm gonna rewrite the entire game in Haskell. No, I'm just kidding. It would be a cool project though, but I'm just gonna get stuck. Okay, but let's see. So there is something weird with the load. Yeah, I think we removed that. Okay, now we have it, but it's crashing. Oh, possibly. Okay, yeah, this is like write only, and we can catch. Well, we are catching it above. Haskell is a ton of fun if a bit brain melting, but Sig is way faster. Yeah, I have dabbled a bit in Haskell like a long time ago, but and I did get quite far for me, but then it was like you wanted to try some library or something, and it had like super weird types and all the different, you know, the features you have to enable on the compiler. Like it was just too much. Like just to use like a simple library, you had to like do a lot of stuff to make it work. Or I guess it wasn't simple. I guess it was like a web server thing where you defined routes and you defined stuff, and it was all like embedded in the types, of course. And yeah, it was impossible for me to understand how it worked. If there was like some weird error you get like an insane amount of text and you don't understand anything. So you basically actually just tried an error to make the error go away. Yeah, getting into a new library in Haskell requires reading 5 pairs on computational theory first. Yeah, that's the feeling I got as well. I do like the lens library is really cool. But it feels like it's too advanced for me. It's like I really love learning about like monads and functors and applicative and all that stuff, but and the streaming, like the FRP, like functional reactive programming stuff, that was also cool, but I never got that much into it to actually do something with it. Find not found, yes, but I am. Why is it unwrapping it? Okay, load, save. We're catching it here, and then we're supposed to. A real path. What? Okay. Man. This is one thing that I don't really enjoy. The file path stuff. Ignores. So does the file have to exist? Like what? That doesn't make sense. Or am I stupid? Your editor is no longer on stream. Oh, sorry. Thank you for telling me. So, okay, I got this error. Name not found, file not found. From trying to get the path, like turning a relative path to an absolute path is basically what I'm trying to do. So I didn't know that you're supposed to, it was supposed to exist already. That doesn't make sense to me. Like, why do I get a file not found error here? Also, the documentation here is pretty good. I don't mean to be too. I don't mean to complain a lot here, but yeah, I'm just trying to find out what it does. Functions. Okay. Yes. Does it return an absolute path? Is what I need to know. Will not convert relative path to absolute path. Use real path instead. But how? Right? I don't think you can resolve a path with a real path that doesn't. How would you know where it points if it doesn't exist? Well, okay. So let's do this then. I just want to create a file name path here. So okay. So I'll do this. We'll create this. Okay. So now we have that. Then we will resolve, or I guess we can just use join or resolve. Let's just use resolve, whatever. And this will be this, and then let's see. Right? I mean, I don't know. To me, it makes sense that there would exist some function that takes like a path that may or may not exist and turns it into an absolute path. Because that's like I would think that's like a very normal scenario, right? Or am I crazy? Okay, and then we let's just deallocate it. Doesn't matter. Okay, we got a crash. Alright, because wait, but this returns an absolute path, right? Canonicalized absolute path name. I don't know, I'm just trying to create an absolute file path. Yeah. Oh no, I'm stupid. I'm freeing it before I'm using it. Okay. Why make it absolute? Well, I was just thinking that it's easier to pass it. Let's say you store the saves in some, I don't know, user directory. I don't know where you would store it, but I was just thinking if it was like easier to pass around an absolute than a relative. But I know right now it's not really that big of a deal to have it absolute. I'm just baffled by this like sometimes how hard it is to just get an absolute path. And it complains, yes, what is this? Oh, I never actually... I just want to see what it is, because it says it's not absolute. Maybe join instead of resolve. Pretty sure you have right only twice. Okay, I'll check it. Okay, that's good, and that's good. So it says that this is not absolute. I don't understand. Okay. Anyway. Like the save, we're opening it right only. Yeah, they should be create. That's right. Because oh yeah, so open, it requires it to exist. Is that the thing? Is that a whole? Okay, did I read the error wrong? I'm pretty sure it did complain about absolute path at one point. Maybe now it complains. No, it does complain here. But maybe it's actually checking for it to exist though. No, or is it? No, it's not. Okay, you know what, whatever. Truncate through, yes. Okay, will this fix the issue? No. Or it still crashes. Yeah, so I don't understand. Oh, it's in the load. But oh, hang on. Wait. Okay, this is save load. Save file. Save files from there. Loading. Oh my god, okay. My bad. Wait. I passed it. Okay, let's do it like this. It was the wrong order here. The terrors, or I mean the perils of actually passing in the same type into a function like this should probably be like a struct or something. And then we have game scene transition here. We are also, yeah, this is the transition is also wrong. So I assumed it was the second one, but it's actually the first. That's a tricky one, actually. Well, it's, I mean, until you find it out. Game init. Let's see. So first is save, then that, and so game. First is saved, then it's, okay. So it was the same there, and then game load. Here's the other. It should be like this. Oh my. Okay. All right. Okay, we exit. Did we get any weird errors here? No. Okay, so we should have a file here now. What? What the hell? Oh. I installed the, well, I probably installed the requirements for this, but I have to install the actual tool itself, it seems. I misread the installation notes. Okay, but we should have a thing called save file. There we go. Let's see if we can use Seaboard tool to read it. It would be cool to be like a Haskell master, but it feels like you could be probably super productive if you know just what you want to do. But I don't know. There's just so much to learn. But there are a lot of concepts. Like the first time I learned Haskell, I needed to sort of, it felt like I needed to like rewire my entire brain in order to try and think functionally. And then what the hell? Do I need to restart? Cabal. Where is Cabal binary? Okay. Does it work though? Well, I guess it should. Is the okay? Do you recognize the text here, or is it something else? Dump JSON. Okay, cool. Hey, cool. So we get the version here. We get the things. Okay, nice. I mean, I guess it doesn't have to really spell this out. I don't know. Well, it's good for. It's good for. Debugging, yeah. Nice. What if we open it? Okay, cool. How did you? Is it like? What was the thing where you said like? I don't know. You could turn it. You could use. Oh wait, that's a. There was some tool where you could turn it into hex. I forgot what it's called. Alright, so it works. Nice. Thank you for the library. Cool, cool, cool. Wait. So let's go to save. And yeah, there we go. Let's do this. X dump. Did I type something wrong? I've got no. Oh, do I need to do this? Wait, then I've. Is it O2 or O2 or O2? There we have some hex. Okay, but there was something else like vim hex. Okay, there's a tool called XXD. So yeah, let's do this. Yeah, so version. So that's the value, right? Maybe. And then there's some more like information, I guess. I don't know. Maybe it's like super packed and stuff. Okay, but anyway, cool. So let's try. Yeah, I might read into it a little bit. Right array map. Yeah, so now we should see, hopefully, except now we get this type F64 writer map count right header size size writer. Am I putting in the correct stuff here? This is the map. So which function? Right value, okay. Well, it might happen down the line, but yeah, but these should be like values. No, I'm not loading. I'm trying to write a. Well, I guess I could. I guess I could start with loading that only that part. But I was trying to write the array or the hash maps. Yeah, I don't know what the error is. I'm trying to figure it out. So there's an error here. So there's a union. Which union is it trying to read? Wait. Okay, I think if we go here, go to quest states. So this is an enum, right? But the state is a little bit different. We have bools. This one is usize step state. This is a union enum, which has a F64, U32, and MPC key. This is basically just a string. So it is really pretty simple. I'm gonna guess it has something to do with this because it says F64 here, but I don't know. Union enum, okay. And what does it do? It's trying to look at the type. Union, we get the info here. So this is the enum, and then we're looking through the fields and we're checking if the value is equal. So this is like checking for the tag, if the tag is equal. Wait. Yeah, if the tag is equal. And then it sets v, which is a, what is that, a type? Right, it says here that we're trying to access the value, right? The value, the runtime value. But this is saying this is a type. Because it's void. I guess void is a type. And then it says that this is a type. So let's see. Am I using it wrong, or let's see. Not sure if this code is correct. Right, this? Yeah, because it looks like V is set to void. It's also comp time, so maybe this shouldn't be value. Maybe this should be like. Is there a test case? Yeah, I'm trying to find it. I don't find anything called union in here. I wonder if you could somehow get around it, but when it's a union, you need union in it. Yes, if you have the name like this of the tag type, you could use that. But that's for creating a new. This is just accessing the value that we already have. Yeah. You can get around by writing your own CBOR encode. Yeah. That's right. And CBOR, you just pass in the writer. Okay. So we could, yeah, and the good thing about tagged unions is that you can actually define the function here. But does it support errors? Like if I have an error here. Because there's gonna be a lot of try write. Oh, value. Oh, it needs self as well, of course. And value is just the thing that you pass in. Okay. I was checking if it had like a pointer or something. Okay, cool. I think the right array line 233 should be moved into the inline to avoid the comp time bar altogether. Right, so here we see that the arguments, so this is the actual, wait, so this is the, no, oh, this is arguments. So we're writing this array here, so we're writing first the type name and the tag name and then the value, I guess. Well, I think the issue is this, the type of this. Like if we set this to, I don't really know what we would set it to. I mean, we should set it to like the tag type, tag payload of type of value. Tag is well, the tag is, oh yeah, this depends. Wait. So if you, yeah, if you do this, that was what you were trying to say, or what that you said here, that we do this, and instead of assigning the thing, you do this there. Yeah, the tag type to fields known only inside of inline 4, yeah, like this. Okay, so this is gonna be the, well, actually it's the, what is this? Oh, info tag type. Well, the tag type is this. T. No, wait, what's, yeah. And this is field. Yeah. Wait. This is a union. Yes. Okay. Okay. Now we don't get the error. Nice. Let's see if it saves it. I think there's like at the start there's no actual entries, but we'll see if what it says here. Let's do wait. No, let's do Seabor. JSON, what was it? Dump JSON save file. Oh. Okay. We do get this here. Okay, that's a sign that it works. Cool. All right. And then well, yeah, so let's try it out. So if I go over to this thing, whoops, if I go over here and I will say accept this quest, we exit and we go over here and now we check. Okay, here we go. Yeah, so we get a quest here, gather gems, it is accepted, and we have the progress and stuff. I mean, I guess this part is maybe not necessary to save, but whatever. Just the index, because these are, I mean, they are static. Okay, but yeah, cool, it works. Awesome. It's really cool that you can like just use this tool to dump it as JSON and stuff. And probably get a lot of other benefits of using a standardized format. Yeah, okay, let's just enable these, I guess. No errors. Okay, so let's try and run. So it's the same for decode, I guess. If it has like a Seabor decode, it will read. Okay, so if I do this, now it should have saved the dialog state as well. Well, that's the only thing it has saved here. Here we go. So here it defines, okay, Elder should now start with Elder start 2. And then this is what options are currently available. Alright, cool. They don't actually differ from like the default ones. So it's probably not necessary to store those. But yeah, whatever. That could always be like optimized later. All right, nice. Okay, so let's try and read now. Let's remove this crap. All right. So we open the file. We make a reader. And I guess it should be sort of the same thing here, where we can now, is there like a read? Wait. What is it? Match. What's it called? Match. Oh, you need an iterator. Wait. I mean, I guess I could look for in a test. Decode direction doesn't have a reader interface. Okay. How do you create the iterator? Decode type. Is that what you need? So you need... No, wait. Oh, is it... Wait, what? It's a pointer to a slice? The reason is this allocation free, so basically you have to read the whole file, then use the match extract. Oh, okay, okay. So what we'll do is we will read. Yeah, let's just do this. But then we need an allocator. I guess we'll just pass that in. Okay, so we don't create a reader, we do read to end, and we get the file contents there. We max bytes. I don't know. Shouldn't be that big. I mean, let's do 4 megabytes. If it grows larger than that, then we have to optimize. Maybe, I don't know. 4 megabytes. I mean, maybe it's not that big. I don't know. We'll see. We'll see what happens. I'll just put an arbitrary number there for now. Not, yeah, so this could be an error, so let's just do try. Four megabytes is a ton of state. Yeah. I was thinking like it could grow very fast if you put a bunch of strings in there, but and as it is right now, it only stores the state that has actually changed, I believe. So yeah, it's gonna grow. It grows as you like play the game as well. Final contents, which maybe that's bad actually. But we do have the version, so it shouldn't. It should always be like retraceable. Wait. So now we have that. What else do we need? We need. This is kind of the iterator here. But it needs to be mutable, and then so what does decode type do? Is that like keyboard type? So you get some generic like information about the next thing to read, but okay, but that, I don't need that. I don't think I'm gonna use then match. So what is this? Match pattern, like any match value. Oh, I see. You pass in. You can pass it in like this. Probably don't want to manually use the decode functions. You want to use match and strike. Yeah. 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 Okay, so match. Let's just do match. I mean, we could just use match value, right? This does a bunch of comp time checking for the types and stuff. Yeah. Just to make it easy, you know. And then, yeah, start off match value, yeah. So this would be, but now, wait. Yeah, it's a pointer to the thing. Oh yeah, this was the other function. So yeah, so file contents, and I would actually advance the slice, I would assume now, because that's where you like have the state of where you are. That's cool. And then value is value, type of value. Okay, so I was thinking first if you could like have a pointer to the thing that you want to change, but you will do, well, let's do save and then I guess this is bad. We'll do this first. Or match value with advanced iterators. We want to copy file content, like more iterator file content. Yeah, if I want to use the original slice. The value to match can be a literal value, zebra type tag, enum, or an extractor object. Okay. So you want zebra extract version to read the version. Okay. So you could do. I'm just thinking of a nice way to do it here. So let's say. Well, okay. Maybe we do it this way, and then like save.version. Oh, so you're saying that if I do like this, if I do this, will it store now in here? Will it store it in here? I don't have to say like save.version is equal to this. Have to wrap it in an extractor. Okay. Oh, I see. Okay. Oh, I see. So like this. Extract. Ah, I see. I missed that part. Sorry. Okay. Cool. I was thinking you were calling the match function, but you were calling extract. Okay. Nice. Yeah. And the reason I didn't want to create a save like this and then is because we might miss you might miss like stuff in there. Like it's safer to maybe create the variables first, or even constants, and then map them each like this. That was what I was thinking, like version, and then it's like match value or whatever, and then it's like, I don't know, can it be a type? Can you do this? I'm guessing no, because I don't see type here. Because then you could do this pattern here. And you don't like miss stuff in save. Oops. Well, let's do it like this for now. Maybe we could do it in another way. Oh, they return a bool. I see. Well, let's do try. And if it matched. So if it okay, but now but now when if I call this, you won't get like a mutable slice, right? Like the slice won't actually be mutated now, right? Or am I missing something here? Yeah. I mean, yeah, because I want to build it up with a series of match stuff, right? So now I can keep using this. Let's just call it iterator, just to have it. Yeah. Yeah, that was what I was thinking. That it doesn't use. You have to mutate it. This copy here. Okay, but now we have the version, and now okay. But the extract thing is nice. That's a really nice solution here. Okay, and then we do primitives. This should just be readable, right? It's just a simple thing. And Right, so now we need quests and dialogues. All right. You want to keep file contents, you can free it at some point. Ah, that is true. That is true. Okay, and this is a question here. Like, okay, iter is mutable. If I do defer here, it's gonna call this on a mutable, which is bad. So you can't do this because at the end it will be like mutated. Right. So if we do const file contents and we free it, oops, and then we have iterator, which is no, it's just a copy. That's right. Yeah, iter is consumed point somewhere else. Yeah. I was thinking also like when you do a defer, like there was a pattern where you had like the return value depended on. Okay, I can't even think of the example now because yeah, I don't exactly remember how it worked, but like there was a question like, okay, when you return okay, it was like this. So let's say you have x equals 5 or something. We return x, but then we defer something. No, I don't remember. I don't remember what it was, but it was basically what order. Wait. Now it's basically x, and then x gets mutated. But we return. Okay, this looks stupid, but there was a thing where I had that happen, and it was weird. Okay, anyway. Note, if you extract strings from the CBOR, they will be referenced inside file contents, so you have to be careful when you free it. Ah, okay. I see. So you have to duplicate the strings, is what you're telling me. Alright. That's fine. That's good to know. Thank you. Right, so now we basically, I want to read the map now. Read or match, or let's do, wait, this is bad. This is weird. I just need to return save here. So I want to, well, let's follow the same pattern here. Match map, iterator, extract, save quests. There's also extract allocate alloc that will use an allocator to make a copy. Okay, cool. Extract alloc can also extract more types like arrays that need allocation. All right. Nice. And this would be any type. I guess this would return this. Oh yeah, it was also like, if this goes wrong, we just do this. Okay. All right. So, what do we want to do here? We want to mirror the right. So, first we read the count. Wait, is there like a match? No, so this would be... Okay, so... Okay, this is interesting now. Because how do I know what right map header... How to read a right map header? How would you... Like, how would I know the format? I mean, I could go in and check the code, but... Wait, type value... So it just writes the size, I guess? Because the issue becomes that if the map header changes in the future or something, then we have these like custom read like matching of the map headers. Extract alloc. Right. Now the value is gonna be it's gonna be what is extract. It is the extractor type of thing, which is gonna be this. So we have a destination T, okay. And we have an extract function. Okay. You can use decode array header or decode map header to read. Ah, okay. Thank you. So decode. Here we go. Decode map header. Okay, there we go. Right. Now, the thing is here, I probably just want to put this, and this would be the map pointer. We can't have a... No, never mind. And now here we do extract. No, wait. We're just gonna read the length. All right. then we're gonna loop. Wait, doesn't map stuff, they have like assume like capacity. Where's the thing? Here. Ensure capacity. Ensure total capacity. Here we go. So we'll do map pointer ensure total capacity. Right, and now we have that. So now we can say, no wait, put assume capacity. And we also need, this would be, so we need a key and the value. And we're gonna, I'm just gonna, well, this is assuming capacity. This needs catch and reachable, yeah. I guess we can do a try since we have it. Oh, the code mapper actually returns the length on the map. Oh, okay. I should have checked the signature. Alright. So this is the, okay, that's good. There we go. Alright. And then we don't supply anything. Okay, cool. There we go. Okay, that's nice. So now we need match value. Right, so if we, so you're saying if we do string, no, value, okay, I think we're gonna have to do it like this. Since we're in a loop, we can't really allocate in here, or I guess we can. But if there's an error now, and we wanna deallocate everything that we've done so far, we can't just defer in here. We have to, I guess if we have access to the counter, maybe we can loop through it. Or how does defer work in 4? It should reset every loop. Iterator, yes. Now this would be extract into key. Now key is gonna be type of map pointer wait, how did we do this over here? We don't do it over here. Well, we get the key. We have the key from map.keys. So we could say, well, I know there is like, data list, or I don't remember what it's called. Entries, and then that one had something. No. Oh, it's KV, I think. Yeah, KV key. So we could say type of that and then KV, and then we say the field well, it's gotta, we could do type info dot struct, no wait, no, let's do field, actually we have field type, that's right, field type of this, and then the key is, or the field is key, there we go. So now we have that, and we set it undefined. There we go. And then we do same for value. Return. Right, we don't need this. And then we put assume capacity, and we return, whoops, true. Well, I guess, you know, we can return false here actually. Just return false. Maybe. No. Let's return error. And then we do like defer. Defer, but now we don't have I. Yeah, I've been looking for the hash. So I'm using this. But I'm not sure. I mean, I might have missed it. You have KV, which I'm using to get it out. And then there's like data list, hash. And this is the hash type. It's not like the thing I'm interested in. And then there's a bunch of functions. Whoops. There's a lot of things in here. Okay, so I mean, I have been looking for the actual types themselves, but they are, maybe it's this one, or is this the same? I don't know. I've been just accessing through this type here, right at the top, but these ones, I don't know if you can access these. They are like parameters in the function here. I don't know if you can you access those? I don't think so, or at least I don't know of a way. But at least I mean, yeah, this should work for now. Okay, but the problem here that I'm facing is like okay, let's say we have I here and we do an error defer. Now this will play out after, wait, let's say key is stored in the alloc. Actually, maybe it's better to do this. It's better to just don't allocate here, and then at the end we go through everything again, and then we say map pointer keys I is equal to allocator dupe. Wait, but the keys are if we don't know if they're strings, so we should only do this if they are actually strings. Also, we need to do it for every. There is some values that are actually strings as well. We need like special cases for those things. If k, no, if k is a string, I'm just gonna assume it's this type of string because I'm not using any other else, then we duplicate k equals, no, k, yeah. Actually, let's do try. And if we're out of error, out of memory, then we just crash, you know. By the way, Seaboard allows keys that are not strings, but JSON doesn't, so you might want to avoid non-string keys. Right. Well, I do have non-string keys. I have like enums. And I also plan on turning everything into non-string keys, actually. We'll see what happens here. So, well, it did seem to work. It worked for, no, it worked for quests as well, because it's like an enum. It's an enum with a name, so I guess the name was the string or the key, I think. Okay, we'll do this. And so that's the quests. Now we have to check, okay, do you include anything that is like this one, turn into, that is an NPC key. So this is actually a string. Wait. Well, okay, let's just keep going and we'll see where we end up here. We also have dialog dot options and dialog dot story dialogues. Right. Now the quests. What we need to do is we need to go and, well, what do we have? We have quest state, so dot progress. Oops. Progress dot current step state. And then this is a union, so if this is a turn into, okay, let's name it something sensible here. Okay, and then this is a string. So now this would be duplicate and itself. Enums recorded strings tag name of hold. Yeah. Nice. Okay, and that's the special case we need for those. What about options? I don't think there's anything going on here. The state is just a bool, and for these ones it's just a enum, so this should be fine. All right, that should be it, I think, for loading. Cool. Now, yeah, and we're duplicating all the strings that we need. Oh, what's happening here? Did I forget some? No, I just wrote this. Right, so now, so when we load the save now, we need to grab a couple of things. Let's grab all these. Although the player might not actually exist yet. Maybe we should store the save in the state here. Wait, where is it? Right, so, but what we can do is we can restore the quest container and the dialog container. Right, so if we're saving properly here, I mean, I put, you mean the temp save, I just put it there for now because I'm not exactly sure how the save system will work. So this is just a temporary thing to try it out. So I just, you know, I just did the most quick way of doing it. But actually, that's true. But okay, I just realized we probably do want to have it optional because I want to use it further down the line. That's the whole point of having it here, actually. So I do want to use it further down the line to initialize the player and yeah, the NPCs as well. Well, the NPCs are looking for these things. Okay, that's fine. Yeah, this is yeah, undefined. Tend to avoid undefined because it always binds me further down the line. Yeah, it is so true. It's true. Okay. Now, if we get it, we have a bunch of stuff that we can do. So this one, I mean, this is basically empty from the start. So what we do is we go through the temp save. And this should exist at this point. But let's just do that so we get the type better. Okay, and we'll go through the dialogues. Let's start with those. And this would be, I mean, let's just do this. Oops. Now we get the key is gonna be keys. And here we're gonna say starting, and we're gonna do put. Should be assume capacity. We could also do dialog container starting states and ensure total capacity with say dialog starting dials count. Actually, okay. Anyway, so we ensure the capacity. We can assume the capacity here. We will put the key in there. We will put the value. I mean, we can just copy the value because it should be copyable by this point. Okay. And then it's going to be the option states. You will be options. And this would be, so this could also be, this is like generic for each map as well, so we could generalize this as well if you want. Alright, that was the dialogue. Now we can do quest. What? Okay, at this point you should be able to do like const cast, right? Because you're turning. Wait, shouldn't you be able to put to well, okay. To me, it basically it's just that this function says that okay, I'm not gonna change your array. I'm not gonna change anything here, so it should be fine to pass this in. I don't know. Declare. Oh, okay. I don't think it should be var. Because it's supposed to be a mutable slice. The problem is the inner type. This is like a mutable thing, but I guess what if we do this? Or I mean this. Yeah, that works. Yeah. So it's weird that you can do that but not pass it in here. I don't know. Maybe it's not weird. What is this? Type. There's no members. Okay. There we go. It can't infer the iter type at the match call. It can only infer at the declaration. At the match call. Oh, okay. Right. Switch must have all. Oh yeah. So if it's something else, we don't need to do anything. Now this is gonna be a pain in the ass to keep track of this. But I mean, we could use extract the thing that you said, like cbar extract alloc. This would take care of this, right? So that it allocates strings, any strings it will encounter in the values. Because right now this should be fine, I guess. Save primitives, quest. Oh, I see. So extract iterator. Oh, so it can't. So it doesn't handle structs. So I get this error. No field member function name, cbar extract and save primitives, quest state, and blah blah blah. So all of those are structs basically, and I'm using cbar extract on those, which does not seem to be implemented here for structs. So it tries to call cbar extract, which doesn't exist, and So I have to like provide this function here. And we get the iterator. And this would return, I guess, this. And alright, so now we do these things. So let's see, extractor. Yeah, I could generically map abstracts to seaboard maps, but they do that for some reason. Okay. Yeah, I was like, oh man, I should just write it here. Peers.com. Okay, cool. I might do that. We don't have access to this type. No. Well, okay, so let's do this instead. Let's do like match struct or something. Those things. Wait, is extractable? Is extract method. Is extractor, but that is not public either. Has extractor tag. I guess I figured if you have extract, you probably want to write a seaboard extract method, but it doesn't have to be the way. Yeah, I mean, if it's only like a simple, it could easily be automated. Okay, I think I'm gonna do it like this. I'm gonna assume that this is like a pointer to the struct right now. This is not supposed to be, you know, in like the PR or whatever. I'm just gonna assume that this is a struct and that it is some sort of pointer to that. And so then, actually, what we could do. I'm just gonna do this for extra safety here. T, and then this is a pointer to T. There we go. And then we're gonna do inline for fields on T. I'm gonna get the field here. And then we're gonna say fields. Well, actually, seaboard match. Value, and the value is gonna be, oh, that's the iterator, and then it's gonna be seaboard extract value And now it's gonna be field value field name. And if that fails, return false. I'm gonna try, or here, try that. Right. You could copy the whole extractor, add a struct case. Ah. But what about matched value? That needs to have... Oh, this could match this... Wait. No, it says here match error. This can't match structs. So I was thinking... if we just do this, and I'm just gonna assume that the input is a pointer to the thing that you want to change. Not match the extractor. Yeah, but then we need it for match as well. Okay, I'm just gonna try this now. Match. So this would be, no, not that one. Over here we have match struct, and we don't do this. Oops. Also, this should be inverted, right? This should be not. If we didn't match it. Your logic in match struct is back to front. No, you're iterating the CBOR key and value pairs. Oh, I see. I see. Right. So we have to. Oh, okay, okay. Okay, well, let's do this. Let's do fields. So we'll do for length. Don't need to capture it, but I think you have to. Write that, and we do capture. First we do the key, which is gonna be a thing. That is gonna be the key. So there's the key. Now we need to find the actual field. There we go. Right? You didn't decode the map header, but it's not a map, it's just a struct. How does that work? Do I have to so does it store the struct as... Okay, so I have to put the... This is the. Okay. This is this one. We're writing just a value, which is this this struct here. Actually, we could go in here and check. Here's the struct. It's not a tuple. Well, okay, so this is actually a map header. So we first you're writing the length of the struct, and then the key and value. So it's basically the same thing as a map, except this like works for. Okay, so we actually have to read. I guess we could do this. Seaboard decode map header. If len is not equal to this, then we have some sort of error here. Fields, number of fields mismatch or something, I don't know. Yeah. Oops. A bit of JavaScript slipping in there. Okay. Okay, so now we have match struct. Yeah, this one. Right, so we're going through the number of fields that we have. We're looking at the key, and then we're matching the key here to the thing that we actually want to populate with. We're reading the value, and then we can break here as well. By the way, I'm not sure comp time iteration order of struct fields is stable, so you might want to be careful assuming that the map fields can be read in the same order they are written, at least. Well, that's why I added the double loop here. So I have one loop that goes through the number of fields, and then I have this loop which checks for which field you actually matched. Yeah. But yeah, that is true. It should be good. We'll see. So now this one needs a type, which is primitives. There we go. Now you are complaining here. Function with null void. Okay. Return true. Right. Inventory, quest state. Yeah. So okay, so okay. Now we're in the same position here except for inventory now, because it's like nested. You can get rid of child type from the pointer parameter. No, you can't get the child type from the pointer parameter. Oh, you mean here? I just put the type in here just to be like extra safe right now. I'm probably gonna change the interface of this function later and have it as your other functions. But right now it's because I don't accept an extractor here. So I just do a very basic version here. And but the issue now is, well, what we'll do. Oh, you mean, well, yeah. So we can get the type. We'll check for the type here. So if this is a, well, if the field type is why don't I get this here? If the field type is a struct, yeah, I see what you mean now. If this is a struct, then we will call, I will do this. Oops. Except we don't do this, we just do that. There we go. Alright. Wait. Oh, you need this. Okay. Yeah, but now we have quest state, dialog option state, right? So, well, it doesn't work recursively for everything yet, until the PR is in. But let's see. It could be. We could do. Yeah, I mean, we could just do this. We could just say, if actually let's just do this, match value. I'll just do my own thing here. Value is pointer to that. We'll do the check here. And this will be T. Oops. So if that is a struct, we will match that with the value, and otherwise we will put it here. There we go. Return true. Okay, so now we can do, instead of doing this, we can say if not try match value, and the type is field of type, the iterator, and the value is gonna be field. There we go. Alright, and then over here we will do so let's remove this. Right, and so we'll simply use this instead. Well, actually that will be value, this will be this, and then this will be, I mean, it's just gonna be, yeah, it's gonna be V. There we go. Step state. Right, so now we have a struct that refers to a union, which then is a struct. So now we're we have that going. I mean, I guess technically you could like copy this maybe, unless, but it does refer to things that doesn't exist outside. I guess we could cover the union as well. Where is that? Or the enum? No, wait, where? Match value, int struct array. I see. Wait. Wait, I'm confused. Lord, you're going to end up duplicating some of the libraries. You could have just added ZBrush to your project. Yeah, I wanted to use the built-in Zig fetch feature. Okay, you know what? Send Matteo very welcome to do that, by the way. Okay, cool. Well, yeah, I mean, yeah, we'll see. I'll see if I could probably like push changes to it, I guess. Let's see. So match. So if. So else if it's a union. I'm gonna. No, that doesn't work. It doesn't work. Oh wait, it doesn't work actually. I mean, it does work if we capture this. So if it's a union, we will do what? Actually, no. So there's no match union here, right? And so I'm just thinking of how. Okay, I have to look. Where do we write? So you write a union like this. Right, so if there's no tag type. Right, then it's just an enum. Wait. Right, array. I mean, I guess we can just do this, and we can say we could just copy this here. And do the same stuff. So if I mean, we should probably do a switch by this point, but right, and this is where things went wrong. Right. Last time. So we'll do this. Well, we don't want to write an array. So if it's an array, if the value is, so we want to read I'm trying to understand like where the array comes in. V is the one field. We're writing an array with a type name, tag name, and that. Why do we write an array? So args is a struct. And then we go through each field of that struct and we just write the value. Okay. I see. I see. And we also write the header, which is just the length. Oh, I see. This is the thing that you're writing. You're writing the type name and the tag name and then the actual value. I see. Okay. I was like, what the hell is going on here? Why are we writing an array? Okay. So now I understand. So we want so first we want to read the header, right? So that's gonna be, well, that's gonna be like a decode thing. So we'll just do cbar decode array header. Right, so try. So now we have the size of the array, and it should be 3. then we should read 3 items. So the first is the type name. Which is a string. I guess we can use string directly, so... Oh, so if you do this, does it populate the string? I'm guessing. How would you get it out otherwise? Right, so we're decoding. Ah, okay, so we're decoding. I see. Right, so we are populating. Okay, cool. So we're matching that. If it's false, return false. So now we have the type name. And then we need a tag name. And then we read the value, which is so now the value is the actual value. So this is gonna be payload of T with the tag. Well, so now we have to match the tag. Okay. So now we can do it in line 4. And we can say if value is equal to that. Well, we don't have. No, so now we have to do if tag name is equal to tag name of, well, actually, U field name. Okay, now we know. Now we can do this part. Alright. And we match. Actually, what do we match here? Yeah, we want to match the payload, so and then okay, so now we have like the type name, the tag name. Wait, how do we get... Okay. So the type name is interesting. I mean, we should know the type. We have the type is T. The type is T. So it's basically the type name just needs to match the type name of T, I guess. But I'm just gonna ignore that. Decode types decodes the seaboard value type. Okay, so that's different. I'm gonna assume, because what I wanted to match was like this type name. I'm not sure. Maybe we'll just throw it away. Probably. And then we have the payload. Let's see. Remove this part. And what am I missing here? So payload is tag payload of T. We define the payload here. We try to read the payload. Now if we get the payload, we want to we want to set value to be union init, right? No, union init. The T, this is T. The field name is, we can use tag name here. Well, actually, this needs to be comp time known here. So we have to do this. And then we have the init expression, that is going to be V. Right? Oops. Oh, there's some syntax error here. Okay, there we go. Payload. So the tag is. Wait. This needs to be a tag. Could we use field type instead? Field type of T. No. Let's do field type of T. And we have field type. Okay. Tag type. Well, if we don't need it, we don't need it, I guess. Right, and so if it's not a union tag type, we only write the type. So this is basically like the enum tag. No, wait. This is only the type name. So we don't really we don't really care. I guess we just consume it. Cause we also need to do this. But then what would the value be? Type name. Wait, wouldn't that be like the... No, right. Right array type name of T. Isn't this what we want to write? Not the type name, or what am I missing here? We're trying to write a union value, but here we're not writing that, or is it because the tag type doesn't exist? It's just a union. type name of T, isn't that just the unions type? Don't we need like type name and tag name? And omitted value. Well, okay. Anyway. I guess we could... Where's the thing? Here. Yeah, we'll just match that thing here. We don't have this case in this code anyway, so it doesn't matter. Fields, info fields, no field, name fields, in built-in type. Oh yeah, it's a union. Okay, no more compiler errors. So that means it should work, right? All right. So let's see how does the thing look like now. So we have, right, so you can see here, for example, here we have the elder should say the second start conversation here. So let's see if that works. Probably gonna crash on startup here. Yeah, I think it already crashed. Maybe no. There we go. So predictable. Segfault. Great. Okay, so is this a put assume capacity that fails? Which is over here. So we do ensure the total capacity here. But perhaps that is not enough. Oh, did it already have items? So if it already has the items, what the hell do we do then? Wait, this does make sense. Yeah, we could do an allocating put. The issue is more like there shouldn't be items in here at the start. So I'm just trying to figure out like why that happens. But I guess yeah, we could just do this. Still try, yes. And we'll see. It's supposed to be just a brand new map. I guess we could clear it. I guess it's now it's gonna be like duplicate keys or something. Still like segfault. I think there's a thing called put get or put. Yeah, that's right. Wait, is there something else though? Oh, where is it? Here. Put Get or put. Yeah, I guess get or put. There's something wrong with this map pointer. Hope I didn't railroad hold too much. That's fine. I mean, it is probably for the better to have a better formatting on the files. It was something that was probably good to have. But yeah, thank you for watching. See you later. I'm still gonna stream for, I don't know how long actually. We'll see. I'll be like 1 minute here. All right. Let's see here. So, oh yeah, I forgot about the Twitch chat thing here. So remember that. Okay, so yeah, I think there's something wrong with this pointer, probably. These are, I guess, do we have to like initialize it? I guess. I mean, probably, because the capacity is gonna be like garbage data, so yeah. Oops. Alright, so quests. Pretty sure you can do that. Okay, let's try this. That was probably the issue all along. Okay, interesting. Okay, so let's see if this guy says hi, then it works. If he says hello, blah blah blah, then it doesn't work. Okay, it does work. So it does save. Okay, so we actually sort of loaded the save now. If we accept this quest here, we now have a quest. Okay, and so let's exit, and it's gonna, well, okay, it's gonna crash. I'm just gonna check what this says now. Okay, so we actually did save because we have this quest now, but there was some weird error here. Is this a leak? Okay, there's a leak. Whoops. Which leak is this? Oh, the save. Wait. The key for the NPC. I think it's like the NPC key. Are we not clearing those out? No, because they are like they are all static. From before, so we don't actually do that. Okay, I'm gonna try. I'm gonna have to find another way to do this. I think the NPC keys, we're gonna change those to be enums instead of strings, so then this problem will go away basically. But let's load this up. So we should have a quest now. Yeah, get the quest. So it works. The save works. Awesome. And then yeah. And then let's try and advance the quest. We also have these guys. Yeah. Need to get 5 gems. That's 4. There we go. Now the progress. Okay, so if we exit, reload, then we're back here. That's like a warp, save warp, or not really a save warp. Well, almost. Oh shit. What happened there? Okay, but now you can see this is current index in the steps is 1, so we have to turn it into turn into elder, turn in to elder. Okay, but it failed when we tried to look at the quest in the quest log, so there's probably another type of panic index out of bounds. Quest info. This is this one. Oh, I never put the... Oh, I should probably have a sanity check here. So, the first... So this is like the title of the quest. Here is like description text. But the description text like changes each step. Here are like all the steps. So first... No wait, this is the requirement. Right, on started, on completed. Where's the steps? Oh yeah, so these are the steps. So here's the first step, and here's the second steps. There's 2 steps. here, but then we should also have 2 description things here. So actually, let's do, we could probably say, we do like a sanity check here. If description dot length is not equal steps dot length, then we should get like a compiler error here. So quest description length does not match steps length. Quest is yeah, so now we get it. So now we get this error, and so we add another description here, which is go talk to the elder, or go give the 5 gems to the elder. Right, and now the error should, yeah, the error has disappeared, and now we can start, and we can talk to this guy. Whoops. Okay, yeah, no. I just did. Okay, this is a bit buggy here. It took my gems, but then I canceled. The problem is I allow the dialogue to be cancelled at any time. And so you can get into some weird states. Also, now it crashed for some reason. So I give him the thing. Thank you. I press thank you, and then there's an error. So, oops, what is going on? Right, integer overflow gems. Oh, that's the issue. Okay. Well, I don't have the gems. Also. Wait. Right, so here the action is lose gems. This is kind of weird because we already lost them. We shouldn't get in this position, I guess. It's like as long as you talk to this guy, you have the 5 gems. You have to complete the dialogue in order to actually complete the quest and stuff. So you talk to this guy, you lose 5 gems. But then I cancelled, so I could do it again. But then I had 0 gems. So I guess we'll do a sanity or a thing here. If this is more than the gems, then, well, I'm just gonna set this to 0 and then we'll be fine. Player has less gems than what we want to use. Okay, now it doesn't crash at least. Hello, Palera7. Have a nice day. Thank you. Have a nice day. Okay. Okay, there we go. But the gems shouldn't be lost. Also, are we restoring the gems? So now we also store, now we have 4 max health as well, so we need to check if that works also. Wait, why is everything going up? I just noticed that. So if I exit now, it's gonna save, I load. I'm gonna keep my gems? No, I'm not. Okay. So maybe that was the issue then. Save. Wait, where is like, it's gonna be game init. And Oh yeah. We only do the quests and stuff. So this is happening there. So let's do it after everything, I guess. We will do temp load save 2. No need to. Alright, so now we need the player component. We need the health component of the player. And we're gonna set inventory gems to be save temp save file. I guess if we have it. If, well, so save it's gonna be game temp save or else we return. So now save dot primitives inventory. Wait, what? That should be gems. I guess we could just set inventory to inventory. We copy everything. And then health component max health equals to save max primitives max health. There we go. And if we look at our save, then we should have, well, okay, so it resetted here. Let's remove our save file. Play. Come on. All right. Oops. Okay, I need to check in why everything's moving up. I'm gonna guess it has something to do with no gravity being added. Okay. Particle animation. Spawn points, yes. Right, so we set the key and everything. I don't know, man. Static, okay. Okay, I'll look at that later. Let's see, what are we doing? Well, okay, yeah, I just died. I'm just gonna check. I'm just gonna kill one monster, grab a gem, and see if I can get that. So now it should be saved. Right, so we have one gem there. And we restore it with one gem. Okay, good, good, good. Now let's complete the quest. Okay. Hello. 5 gems. Yes. So yeah, so it did like advance. I have your gems, but now we exit and we should have the same. So I have your gems. Yes, thank you. There we go. The quest is completed. We now have 4 hearts, so we exit, enter, and we start. Okay. So we have 4 hearts, but we start with 3. I mean, that's classic. That's classic video game shenanigans there. But we could actually go and say this as well if we want. So now we start with full health. All right, so great. But yeah, that's gonna be it for this time. So thank you very much for watching and chatting with me here. And so yeah, we did a lot of things. We started out by going through what we did last time and stumbled into the iterators again and modified them a little bit. And I think they are better now. Still not sure about the pattern though. We'll see what happens. But I think I'm gonna integrate it more because I really like the idea of not having to allocate a bunch of lists each frame just to show a list of options instead of just, you know, having an iterator. It works very, very well. It fits very well for that purpose. And having like an iterator that you can also sort of map into another iterator works also very well. So let's see, what else did we do? Yeah, we fixed the monster particle thing, except it introduced another bug, it seems, which I need to actually write down there. So hit particles fly up in the air, possibly because of the static monster death animations. There we go. And what else did we do? I don't know. Was the shield thing in this episode or last? I don't remember. So, and then we also, yeah, we did the whole save thing. So that was actually a quite surprising thing. And we also, yeah, we now have the Seabor integration, or we're using the Seabor sort of binary format, which has support for other, like, which has like major support, it seems.
and you can also read. So it's saved in a very tightly packed like binary way. So it's a small save file and easy and like fast to save and fast to read. However, you can still read it as a JSON with tools, so that's really nice. And although we had to like implement some stuff on our own, but I might actually send some updates to the library to see if we can add some of the cases there. Yeah, I mean, was that it? Yeah, I don't remember actually what we did, but yeah, but I think we fixed some stuff in dialogues as well, the dialogue system. Some errors there. Okay, but yeah, that's gonna be it for this time. So thank you very much for joining me, and have a nice day, and I'll see you later. Bye bye.